So we'll be talking about applying Gen AI to humanoid robotics, and as with the panel this morning, if you folks could just kind of introduce yourself briefly and then talk about why are you here? What do you do with humanoid robots and generative AI?
Cool. Hi, I'm Russell Nickerson. I have a startup called Collabots. It's kind of a consulting thing. My day job is actually Mass Robotics. A lot of people have heard of that. It's like a nonprofit co-working space in Boston. But in the past, I've worked for SoftBank Robotics on the Pepper and Now robot humanoids, and I'm helping a Japanese startup right now on an entertainment humanoid. So just really interested, always in the industry since I was a kid, and it's great, kind of, being here on stage and living the dream.
Hey everybody, I'm Caitlin, or CK. I was driving down from San Francisco, and I think I'm probably the person at this conference who's worked in robotics the least amount of time. I worked in robotics for 1 month as of Tuesday, but my background is high volume, high complexity consumer electronics, so like AR, VR, computers, and things like that. And so I recently joined OpenAI to lead hardware in robotics, and I'm really excited to be here and to learn from all of you.
So I've been in robotics a little bit longer, I think just over 20 years this year. So I started out at Carnegie Mellon. My name's Pras Veligapudi. I'm the CTO at Agility Robotics, which hopefully needs an introduction after this morning's keynote that Jonathan gave. So I spent the first 10 years of my career in academia at Carnegie Mellon working on humanoids, drones, snake robots, all sorts of fun stuff. And then spent the next 10 years of my life in industrial automation, living in warehouses and making robots actually do stuff. And then kind of reconnected, joining up with Agility, when kind of those two worlds met at a particularly interesting time in the industry, as we're all here today. So I'm here because Agility obviously is very interested in exploring and deploying these new generative AI models and technology.
Very cool. Kamate Richards, I'm here with Amazon, but actually more of a personal reason. I am working on a little stealth startup in robotics, in home consumer robotics. But for Amazon during my day job, I really focus on building products, consumer-grade products for generative spaces. So you can imagine we had a lot of interest and hype train around GPT, those kinds of things. But it took building applications on top of it to make it truly viable. So that's something that we really focus on at Amazon.
Kamada, maybe you're the person to start then. Like, where are we with generative AI in robotics right now?
I'm going to exclude talking about the foundation models, as we had that talk this morning. I'll say that the space is wide open from code editing, code assistance. Some of these things are unsexy, but they're absolutely vital. Things like documentation, you can use generative AI to document your processes. Other things you can do is handle exceptions where your reinforcement learning models aren't working. You can step through with a generative model and have that model kind of adapt to the circumstance, and that's particularly good in pick and place robotics. Rather than falling back to a teleoperation, you can use generative AI for that purpose. My particular interest is in automating the robotics software development lifecycle stack. That's my interest. To that end, last year, I created Gen AI created an application that took a Boston Dynamics Spot robot, built the interface to the robot. This is Gen AI doing that. Built the front end, so I didn't build the front end, it built the front end. And then that front end was in Apple Vision Pro. And then we turned the robot on and it worked. Like that to me is where we are today. I believe that's the standard, but there's so much more. I'm sure some others have dealt with some other stuff.
Yeah, and Pras, you have robots using Gen AI and they work, right?
Yeah. To some extent. I mean, I think there is a bridge there in terms of the reliability and determinism of using Gen AI in these technologies. And we think about, we certainly did demos where we integrated a VLM to automatically generate the tasking to run in real time on the robot, or diffusion policies for motion generation, kind of like the foundation models that were being discussed this morning. But there are these intermediate steps that are kind of on the way there and very realistic. So for example, we have our Agility Arc cloud platform where we're hand authoring task workflows. And one of the really promising areas is, well, you can semi-automate that generation and say, hey, give me a human description of what we're supposed to do in the warehouse here. Move yellow totes to the left and red totes to the right. Let me turn that into tasking that Digit can do. And a human can still approve that and say, yes, upload that to the robot and start running. And those entry points are really very short term right now, even as we work out the kinks of like, well, exactly how are we going to grasp the tote, and is it going to be grasped exactly the same way through a diffusion model, you know?
How has that experience been for Agility? I mean, is it something that has been easy for you folks to integrate into your workflow, or is it a completely different process?
I'd say it's been both better and worse than we anticipated. When we shot our video last year on YouTube of Digit clean up this mess, we took a voice command and Digit used it to basically pick up trash off of the ground and put it into recycling bins and trash bins and so forth. It was so fast, we did the entire demo within 2 weeks because a VLM could essentially really quickly pick up on the skills API that the robot already had. And it had some really surprising stuff that it figured out on its own. Like, for example, it picked up bubble wrap and threw it out in the trash, and we thought for a while that was a bug. But it turns out that actually that bubble wrap was not recyclable. Like, it's the type of plastic that's not recyclable where we were running the robot. So that was really semantic knowledge that was getting captured in a very, intuitive and natural way. And that was great. But then, sometimes we'd ask it to do stuff like move around boxes or things like that. One of my favorites was we did the clean up this mess demo at one point while we were testing, and it's like, well, step one is I'm going to put the garbage bin in the garbage bin. And then it started going over to the garbage bin. We had to e-stop the robot because it was about to do something really strange. And that, is that kind of gap where it does amazing stuff sometimes, and then it does really surprising and undesirable stuff other times, and really figuring out, well, how do we turn this into something that we can put into production? And part of that might be some amount of human-in-the-loop approval or editing in the same way that we use code gen right now, and some of it might be this work that's being done with just in general in the industry to improve the quality of the outputs, to basically refine, do chain of thought execution to basically produce better, more consistent outputs.
And Russell, have you had a similar experience?
I mean, when I think of all this stuff, I think of like integrators in robotics. That's the big kind of linchpin for a lot of deployment. So in the industry, it's really hard to get that right integrator with that problem. A lot of big name companies come out and they say, hey, I have an issue. We're running a challenge with Chewy right now. They have heavy 50-pound dog food bags, and they don't have a gripper, they don't know what robot. Using Gen AI, that can enable integrators to find solutions quicker. Not that they necessarily wouldn't find it before, but it gives them more options and more direct kind of connections on that front. I think it's always similar to you're saying, sometimes it doesn't come up with the best idea. Being pragmatic about, okay, let's not just blindly follow and say this is the perfect, this is going to come up with every best answer, but give me some ideas to solve solutions in robotics. I think that's going to help move forward the industry, and because typically, again, sometimes there's a lot of back and forth with find me a solution, and then they try it doesn't work, and sometimes they give up to wait for the industry to catch up. But it's kind of a boost to the industry for OpenAI.
Caitlin, if you're willing, I would love to know just what your first impressions are of how robotics has been using this technology, and what you think opportunities might be.
Well, one of the things I've learned is these emergent properties of AI as we create new models, and so that's an area I'm really watching, because there was an example where ChatGPT T2 wasn't trained to do translation, and then somebody just randomly inside of OpenAI asked it to translate something from French, and it did. And so this is an area that I'm really interested in, actually, is emergent properties and what happens as we go from model to model. Obviously, a lot of people are already using our models and other models on their robots. My goal is to make that work better. And my goal is to make, really at the end of the day, my goal is to make better models so that when you do use them, they just work more of the time. And so I'm really excited, I think, to work with this industry and to start to get to know many of you to try to figure out how we do that. Because the truth is, as exciting as AI is, and you might have seen we have a couple releases this last week, it's at an exciting place. All of that's happening on 2D screens essentially right now. All of that's happening in computers. And I think it would be really incredible to have the benefit of AI enter the physical world more and more and more.
And we've talked a lot about data over the last day or two, and that's something I think we should certainly talk about on this panel. Caitlin, either you or anyone who has something to say, but just where are the data sources for training these models, and how careful do we have to be about where that data comes from, and just how constrained are we by this data availability?
Yeah, I think the answer is we are constrained by it. I'm really interested in learning about the modalities of data that we actually need to feed to the AI models, like what is the data type that we need, and what kind of latency between the data types we can accept. And that's all kind of open questions in my mind. So I'm very excited to see what kind of data we need to inform. But I think it's pretty clear that the better data we have, the cleaner the data we have, the more consistent data we have, the better the model will be, and the better then it will work for our friends in the rest of the robotics industry.
I think that.
Oh, I was going to say, just real quickly. So, OpenAI is a great example of taking a transformer and providing an application on top of it that was distributed to everyone, so we all have access. They had transformers before. No one cared. Not no one, like the common person didn't care. And so when we got OpenAI and maybe it hallucinated a little bit, we didn't care because we were getting something fabulous, fantastic in our hands for the first time. That can't exist in both enterprise, it can't exist in robotics. We can't have models hallucinate and give bad values. So I think the closer we can get to, and actually I believe this whole space, it's infancy, because we're starting to see layers upon layers of services that are stacked on top of these models that then provide that consistency, that provide that security, all the things we need, compliancy, policies, all those things you layer on top of the model. So I don't think that a framework model is going to be end-all be-all. I think it's going to be a framework model plus layers, just like we do it in OpenAI and Amazon Q and all these different things. We layer on all of these like structured outputs. We layer on multi-agents. We coordinate agents, orchestrators, all these things. Code generation, the ability to kind of look back and see if the code is correct. Recursive criticism. We layer on all these things to make OpenAI better and the tools that we have better. I'll stop there. That's my minute. It's a minute.
I'd love to add one thing to that is also that it's not going to be necessarily language models that are most useful for us in the robotic space. I think that it's going to be several different models together that inform the space.
I think right now we're at this interesting point where we know we need data, and also simultaneously everyone has realized that data is extremely valuable and needs to be protected. And so, one of the things we experience is in being able to build out our data sets, which we like to share with other players. We're not trying to build our own large models. We're trying to work with other people to build those models. But there's this stack of authorization of the provenance in a way that's kind of unique to this space, because it comes at a point in time after everyone realized this import. There's no, Project Gutenberg of robot stuff. I mean, there is, like OpenX Embedded is maybe a small version of that, but nowhere near the scale that we have. So we're like trying to license our data all the way up. And then there's also this question of what is the right format. Unlike large language models, which quite literally have a lingua franca, robotics models have a lot of different options in the modalities that can be represented. How are we representing forces, joint space, perception information? And if everybody builds their models up in incompatible or poorly curated ways, you end up with this kind of like data soup that might not really be the best or fastest way for us to build a useful representation at this level.
Those are excellent points. So what do we do?
Well, I can talk about what we're trying to do, which is to get the best synthesis of what folks like OpenAI and other players in the space are asking for, and to provide the best synthesis as one of the robot providers in the space, and looking at what others are trying to produce in terms of the modalities of the data that seem like they make sense, and build up our data set that way. I don't think that's the end state. I think we're still very much discovering what needs to be done there as ourselves and lots of the other folks that presented at this summit, are evolving our technologies. We'll have to kind of solve for that and figure out what is the right data representations and the right ways to exchange, license, and curate these data sets.
If I may as well, it seems like, to me, just as a mental, an exercise mentally, that if we can simplify some of the variables and the differences between the systems, that it's likely that the AI models we train will get trained better and be then more useful for the models that follow some of those same standardizations. It's probably too early to do any standardization now, given where humanoids are, but my sense is, at least with the sensing cluster and potentially some of the ways that we think about mixing different data types together, it could be an interesting place to look in the future.
One thing, when we look at the evolution of mobile, let's say, and 2 or 3 major players evolved out of that, Apple, Android, and some would say a few others. That allowed us all to code in the same way, to kind of understand what needs to be done in the same fashion with 1 or 2 different providers. We don't have that in robotics. There's not a big player saying, here, I'm going to provide actuators, and here's the standard, here's the schema for this actuator. Like a Matter, if you heard of the Matter protocol for homes. There's a defined schema, and every IoT device understands the schema, and they can all talk together, interact, right? We don't have that. And so it's going to take a major player, the Agilities of the world, the Teslas, Boston Dynamics, say, hey, this is our standard, and if you want to follow it and be part of the ecosystem, then it'll work. But then you also have to lower the cost of that actuator that you're going to sell us.
Yeah, I mean, the standards, that's a big thing. I mean, I always think of ROS. A lot of people love and hate ROS. Well, most people love it. And that it's really what it stands for. This is a way to interact with robots, and it's a lot of academia likes that, because it's a place we can say, hey, that's a good standard to go by. But I'm also, I'm always skeptical also of if there's going to be a plateau. So once this stuff is figured out, you have models or solutions to problems that are agility based or sensory based, that are, well, this is the best vision, this is relatively the best motion algorithms, and they'll okay, that's the de facto standard. It doesn't make sense to, I mean, there'll always be somebody chipping away at another project, but it will help industries move forward. But at the same time, business-wise, there'll be a lot of winners. Sometimes, also, some businesses won't make sense. There'll be some chatbots right now. A lot of people, oh, this is so fascinating. It's great. You can talk to a chatbot, but there's social implications. There's what's the point of having an Alexa or something that can talk to you? It's fun. You pay for that every month, like a Netflix subscription, if it's the smartest thing, but it's still just a puck. It's not an action robot. When you do get the action humanoids walking around the world, interfacing with people, that's where it gets more interesting, but I'll give it at least 2 years. How about that?
Well, to your point a little bit about that, I mean, I think you mentioned hallucinations and stuff, and there's some unpredictability inherent in these systems, but we haven't really seen how that would manifest in the physical world, and I'm just curious, what is that even going to look like?
Well, we have seen it because Tesla is a robot, right? Tesla car, and it was fully capable of hallucinating and telling you one thing and actually meaning another, and that can be very, very dangerous. So they put controls in place to say, all right, if this happens, fall back on a redundant system, and if that happens, fall back on a redundant system. So in my estimation, I believe that we're going to have these framework models, we're going to have a control plane that's on top of all these things that says, does this make sense? before we actually give that action out to. And then actually, I think Gen AI, if you're going to think about it in that context, would be more higher order commands and actions, like go to that other room. And then you, on the model running on the robot, would then navigate its way over there safely using all of its sensory data, because Gen AI is actually pretty slow when it does its inference. So even the fastest generative models are relatively slow to actually actuate the robot and get in all the inputs.
O1 has much more higher accuracy in some ways because it's running the same thing through itself and taking the best answer, but it's obviously takes longer. So my guess is we're going to have a hybrid of a reasoning type of model that's helping whatever we're driving think through what to do, and a more moment-to-moment model with a much higher frequency that's telling it how to do the thing, is my guess, but I think it's still early. Y'all probably know more, have thought about that more than I
It's
have.
very early.
Well, I mean, so Jim Fan, who was here earlier, right, with the NVIDIA team, right, they've been pushing this like system one, system two, thinking fast and slow dichotomy of a model hierarchy where you have higher level reasoning and then you have, faster, execution planes, right? And I think we are seeing that kind of hierarchy and stack work really effectively across robotics. Certainly at Agility, as you talked about earlier, we have that kind of time-based discretization of like the lower order, slow thinking, and the higher speed sort of reactive planning and execution framework. I think in both we see hallucination manifest in various ways, really as world state evolution, right? What you can see is inconsistencies in world state, either at the reasoning level, where the robot says, I will put this garbage bin into itself, which is obviously not a world state evolution that can occur, or in something like a motion diffusion policy, you'll see the robot folding, I saw this at a robot demo earlier this year, one of the many towel folding demos that we get to see these days. The robot was basically just folding air for a while, and then it picked up the towel and started folding the towel. And that's the similar manifestation of an incorrect world state evolution at that layer. So we do see it, it's there, and it needs to be solved for. I think one interesting thing is, what's the implication? Like if the robot folds air for a minute, like that's kind of fine as long as overall it can still do the job, to the earlier talk just before this, right? You can fold towels all night, and as long as you get them done, like that's fine. It's separate from safety concerns, and we can kind of separate those out, where as long as the things that the robot is doing are within some envelope and you've got a safety system around that as a guardrail, it may be okay for generative AI to be non-performant, within that space. Again, as long as you're meeting the product requirements. So I think that's how we can kind of phase it in, is it's okay for it to do things as long as it's got the guardrails where if it does have a type of hallucination, the effects of those are simple and non-critical. Like maybe it takes a little bit longer to do the task, or maybe it drops a towel, but that's okay because it's a towel and that's a fine thing to do. So I think we can still work within that framework.
I kind of fall back to just-in-time simulations in the real, when things don't go or don't seem like they're going to go as planned, or something is an undiscovered area and inference is happening, then that's an area I think we should expand, of trying to just understand whether the model is going to be successful before we actually execute it on the robot. Yes, it might take longer. You might require more compute or cloud compute, et cetera. But the reality is then you can ensure that the next action you're about to take is going to be somewhat okay, right? As much as you can.
Right. If you have a question and you want to raise your hand, hopefully we can bring some mics around. And I just want to ask one more thing as that happens, which is something that we brought up a little bit, but I want to drill a little bit deeper on, which is just that to make progress here is going to take a lot of data, and people are collecting that data, but it's a lot of industry that is collecting the data, and everybody realizes just how much value is in that data. And I've talked to robotics companies who do something practical with a robot, and they're making money at it, but they understand that their primary business is the data that they collect. So as we're trying to scale all this stuff and teach robots to do interesting things, is there a way to be collaborative, or is it just going to have to be because of the value there that everybody has their own data that they train their own model, and then that is their business.
Maybe it's naive, but this is my own personal opinion. It seems that if we can find a way to inform the models, the foundational models with the data, if there's a way to do that, then it's very likely the foundational models will be better for the field. How to go about that in a way that's good for everyone, I think is an interesting question. But I'd really like for the models to be really good for everyone and to be able to use, the field to be able to use the same models. And so that's, I think, a key question.
I would say I'm shamelessly plug Rob from Robot Studio, who's open sourced a robot, and the idea is to collect that data from these various permutations of that robot, and then feed that back into the communities. A shameless plug, but I do think that's something that we can do more, share that data, and this makes everyone better. I will say that for the first time the robot's in the home and it falls on a person, we're all set back. So we have to be sure to get it right across the various companies that we have. So the only way to do that is sharing data.
I think for us, it's a little bit of we have to collaborate, and there's also stuff that's unique to our robot. And I think going back to how foundation models are going to be used, it's highly likely that we're going to have to collaborate on those base models, and then we're all going to fine-tune them to our own platforms and our own use cases and so forth. And so we do need to figure out the right way to collaborate, because we're not building our own large models. We don't have enough data on our own to do it, but we are building our own small models, and we're certainly fine-tuning existing models from the open source community and from proprietary models that we're partnered on. So there is that sort of necessity to share, but also there is a sense of ownership once you actually get down to getting those things to work on the robot. So I think you can have both, and that can still be a healthy industry.
Yeah. Really quick, just a scary thought too. Like, what if the government gets involved and they want to make it open? They make everybody play together. It
always goes well when
interesting. So, but academia usually is where it's like a grassroots uprising. I think a lot of industry happens and great solid products happen, but then everybody's always looking for the lowest common denominator and make it cheaply. So, some scrappy kids eating pizza some night will be like, let's just make a whole bunch of crazy dynamic models and figure this out, or who knows, maybe there's some weird hacking thing that will happen. Crazier things have been done. Not saying, not endorsing that.
All right, questions?
You talked about the data format standardization. You talked about the data format standardization. What kind of organization do you see or feel will be most appropriate to actually standardize the various different data formats?
I can tell you that for a second and you pass it along. I think Safety Standards Board is going to be the primary place where we can all agree safety is most important. So if things come out of those, like ISO standards, and things come out of that, then you're more likely to have to adopt it. You have to agree at that point. I think we should try to come up with our own standard amongst us companies, we're starting to see collaborations like OpenUSD for how we handle models, and Pixar and NVIDIA and Apple and Amazon and others are working together on that. I think that's the way we go, is we try to, and like I mentioned before about actuators, those kinds of things, to take an actuator and replace it with another actuator is largely impossible today without some kind of code. As people start to sell these things in mass, you might see some standards erupt out of that.
I think we're in part taking the lead of some of the folks that are building the larger models, like certainly looking at what is being ingested from data sets like OpenX embodiment, what folks like DeepMind and OpenAI and other players building large models have been able to ingest to create successful multimodal models. That's giving us the hints for what data representations we should be building our own data lake of. So I think that's kind of what we're looking to sort of build upon. And I think as we spend more time with this, and like other players like physical intelligence are kind of sharing what works and how they're building up their diversity of data sets, I think there's a lot of sharing that can go on there in terms of figuring out, well, what are the best modalities of data, what's really relevant, what can be compacted out, as we're collecting stuff. But in the meantime, we're just building a data lake of just like everything ever, and we'll project it down later once people sort this out.
Collect all the data, all kinds of data, even if it doesn't even make sense to you, because likely we can use it.
And we don't know exactly what is actually going to be important. I think that's the tricky thing. I think that the instinct is to say, oh, we can take this SLAM data and vectorize it, or like something like that. But it may be that actually raw data or unsimplified data is more valuable to the model. So that's something I'm interested in watching to see what happens.
Yeah, because my question's very much along these lines. I'm kind of wondering if actually the data soup might be better. I don't know, like when you go downstairs, I went down during lunch, the computers that you see from the Altair to the PDP, to the Apple II or the Commodore, everyone has a different user interface, and a different kind of readout. And some are analog displays, some are digital. But as a human, we can, and especially as we become familiar with those, we can read any of them. And perhaps the more that we see, the more examples, the more visualizations, the more we understand all kinds of things. I don't know, I'm going off of nothing beyond intuition, but I'm just curious, like, maybe actually all this random raw data with enough training and compute will somehow, something will come out of it.
Yeah, you can use Gen AI to map data. So we were just talking about this earlier, mapping a five-finger hand to a three-finger hand is actually an easy exercise with Gen AI. So yeah, give us all the data, and the part that's going to be kind of challenging is the sensor data is different. Like there's no two cameras that are the same, there's no two lidars that are the same. So you can't be exactly sure if your data from one thing is going to work somewhere else without it was a form of translation.
My sense is that a bit of standardization in the very beginning will help create a more functional model to start, and then expanding out will be easier, is my guess. But I think if you have enough data from different sources, that will work, but it might take 3 times as long. So it may be that if you can say, okay, well, if we use this field of view on our cameras, and we have this layout for SLAM, and we have this basic understanding of like the proprioception data, this basic understanding of pressure data, and we start with that as a community, that these models get better much, much, much faster, but then they don't stop there. Then you can start to expand out, and the model can continue to be useful. But we'll have to see.
I think the thing that keeps me up at night is that we miss an important data channel. There was a really interesting talk at ICRA this year about, for example, using the audio channel from YouTube videos when building out these models to basically be a proxy for contact physics. If you're scratching against something, that actually tells you about something about the forces you're exerting in the world. And it's basically because YouTube doesn't have a force channel, right? It only has this audio channel. It's a crude proxy, but surprisingly effective. So when I'm thinking about, what we need to be doing here, one thing that I worry about is, we collect these data channels around stuff like maybe force or, depth data when we're using RGBD cameras is often, really underutilized or underrepresented versus RGB data. And so that's kind of more the thing that I'm interested in, is making sure that these modalities are preserved and conditioned appropriately. When we want to be able to then say, oh, like this was during a particular set of tokens style of operation, when we need to connect that up to being able to then regenerate that particular intent. Like, oh, this was a cooking task, or this was a, in our case, we can tie it to the task execution information that we had at that time. So that's what I really mean about it being important to figure out what's relevant.
Even AR data, IR data, you can get from almost every camera, but you have to remove the filter. And like, so that kind of thing is actually incredibly valuable. We found in VR, but we probably aren't in the field generally getting, IR data.
All right, well, we're going to have to end here. I'm so sorry. But please give our panel a round of applause. Right now we have a networking break, so please be back here in about 20 minutes at 10 for the final sessions. Thank you.